Okay, this is 3.1 review question number 1. It says, at what rate and in what direction will the 10 kilogram mass accelerate? Now, what we do is we actually make an assumption that it's going to move in a particular direction, and then if we're wrong, we'll find out later by the sign. So if it's negative, then our assumption was wrong, and we just reverse our answer. I'm just going to make the assumption that it moves to the right up the hill. Call this M1. Call this M2. And so our free body diagram on mass 1 has components acting down, Fg, perpendicular to the surface, Fn, and up the slope, tension. If we're looking at M2, we have Fg2 and tension. You should see that the tension is the same for both because it's the same string. So let's just write our equations for each one. So the net force acting on M1, M1A, is equal to the tension up the slope minus mg sine theta. That is the component of the force of gravity that is parallel to the slope. And for the other one, M2A, it is equal to M2G minus T. Notice that what I did is, because I assumed the direction, the mass times the acceleration has to be in the same direction as my assumed net acceleration. That's why I have the direction that I have here. So tension is positive and mg sine theta is negative. In the case of M2, M2g is positive and tension is negative because tension is acting against the acceleration that I assumed. When I put these together by adding them, I'm going to get the equation m, I'm using big M to represent the mass of the entire system, times A is equal to m2g minus mg sine theta. I just want to go back here and write that this is m1 because you can see it was m1g sine theta. So now I have the information that I need. I know the m2g, I know the m1g sine theta, I know the mass. The only thing I don't know is the acceleration a. So let's just rearrange that. So put the a down below, or sorry, the m down below. Remember, big M is mass of the entire system, 22 kilograms. So just start plugging away. M2g, 10, times 9.8, minus M1g, well, M1 is the 12, times 9.8, times the sine of 60 degrees, all divided by 22 kilograms. You will end up getting A is equal to 0.17 meters per second squared, but it will be negative. So the fact that it's negative tells me that it's actually the opposite of what I assumed. So it is positive 0.17 meters per second squared down the slope. Pretty good, right? All right, let's look at number 2 here. For number 2, let's do the same thing. Make the assumption after drawing our free body diagram, Fg, Fn, tension, Fn, and Fg2. Let's put these in here. Just like that. make the assumption. Let's assume that it will accelerate up the slope. That is, up this slope. I will get, for the first case then, I will get 3.47 times 9.8 okay. 3.47 times 9.8 times the sine of 30 that equals 17 newtons. That's for F parallel M1. The other one is 2 times 9.8 times sine 60. This equals 16.97. What we see here is that these are both basically 17. So we're going to assume that there's going to be no acceleration. And our assumption doesn't really matter because they're both equal to each other.